So, as Paul mentioned, I really appreciate the introduction. Thank you. And the kind words about the agency and our office in particular. Thank you for coming today. Great crowd. I've been fortunate to be a part of a number of these seminars over the years since I've been with the Weather Service here in Chicago. It's always a special treat in the spring, and I've really missed it. So I'm glad we're able to be back together today. Definitely appreciate the invitation and all the agencies that work together to put this on. Who's been to spotter training before? Raise your hand. All right, so most everybody, good. So this will be a review for most of you. This may be some new stuff for some of you as well. We're going to cover a variety of topics. We're going to focus on just a couple slides about the Weather Service if you're not really familiar with what we do or who we are. Then just a lot of thunderstorm basic information, structure, some of the features, that types of things, some visual clues that we're looking for. We're going to go into how you can be prepared, not just as a spotter perhaps, but just really in your daily life, and then help others in your life to also be prepared in what we call simply weather aware. So how can you look at some tools, what's available to kind of help you do that in hopefully a daily process. And we're going to also talk about safety and reporting. So safety is paramount. A lot of folks are out there out and about taking videos, photos, doing what they do to enjoy the storms or report on the storms or observe the storms. But regardless, we want to make sure everybody is safe around these storms. So there's going to be some reminders about how to do that as well. All right, so the National Weather Service, who we are. We're part of the federal government. We're part of the Department of Commerce. We fall within NOAA, the National Oceanic and Atmospheric Administration. And then there's us, the Weather Service. So our mission is pretty simple, to provide information to protect lives and property. The other part of the mission is to help enhance the national economy. Maybe that's why we're in commerce, I'm not really sure. But that's our mission, lives and property, and then the economy. You can see the cost per person per year based on some recent budget numbers, and you can determine if that's a value to you. Our office in Chicago, we're actually in Romeoville. We cover 23 counties between Northeast Illinois and Northwest Indiana. We've got a staff of 24. It's a mix of forecasters and other support staff. So folks like myself, my primary role is outreach, partner engagement. We have a science officer. We have a meteorologist in charge that is responsible for the office. Of course, our on-duty 24/7, 365 forecast staff. We have computer specialists, electronic specialists, administrative specialists, but it's a staff of about 24 people. You can see our ops floor there on the right side of the screen. The image up here, that's inside our radar, actually. We'll talk a little bit more about radar later, but that's the radar. That's the antenna. It's about a 28-foot diameter dish, looks like a big satellite dish that rotates around up in the dome. You see a couple of our LTECs or electronic staff in there. It's so well balanced, it's a precision instrument, right? Despite it being so large, you can actually be up there and push it around with your arm and rotate it around. That's a process they have to do for maintenance, actually. So it's a pretty fascinating tool, very important tool, as are spotters, of course. Excuse me, we're known as a Weather Forecast Officer, WFO. We have a lot of acronyms we like to use. Of course, there's other parts of the Weather Service as well. We won't go into a lot of detail. In Aurora, we have the Center Weather Service unit that directly supports the FAA air route traffic controllers at that facility. 4 meteorologists of the Weather Service work there. National centers, I'm sure you're familiar with these, the National Hurricane Center, of course, the Storm Prediction Center, who we probably coordinate with the most, among others that you see there listed as well. The patchwork of office coverage areas you can see across the country. There's 122 local forecast offices similar to ours, serving all the United States as well as several United States territories. We all operate 24/7, 365. All right, let's shift gears into kind of, I think, why you probably came here is to talk about thunderstorms. So this is going to be a lot of the basics and the fundamentals that we're going to go through here. All right, so let's start with a little bit of observation. What typically happens in terms of severe weather for us in our area. This is information from our forecast area, again, those 23 counties I mentioned, from back to 1950 through a couple of years ago. Basically, any time of day, any time of year is when we can have severe weather. And we have lots of examples over the years of what we call odd times, or out of season times for severe thunderstorms. We think of some of the more notable tornadoes that we've had, at least in the region. Naperville, Woodridge, EF3, that was mentioned earlier. That was at 11 o'clock at night. It's in the summer, that's tornado season, but it's late at night. What are people doing at night? Probably sleeping for the most part. How are they going to get the message? That's one of our big concerns. The Taylorville, Illinois EF3, that was in December on a Sunday afternoon, if I recall correctly. Coal City's been affected a number of times by tornadoes. This is another after-dark tornado in tornado season. And then the Washington, Illinois EF4 was in November, late morning on a November day. So severe weather can strike any time of day. I'm sure this crowd is pretty familiar with that, but we always have to be prepared and we always have to be ready for this. So how do we get thunderstorms in the first place? Well, we need some ingredients. One of those is instability. And we think of instability as sort of the combination of the heating and the amount of moisture in the atmosphere. And when we think of rising air, that's ultimately unstable air, the air's ability to rise. So it doesn't necessarily have to be uncomfortably warm outside a super hot, humid day to have unstable air. We just have to have temperature differences through the atmosphere. Ultimately, warm air starts to rise. As it rises, it cools. As it cools, we get condensation. Water droplets form and fall out of the air or go into the air, and they eventually form clouds. And then when we get clouds, we might have the ability to get showers and maybe thunderstorms, depending on the balance of all the ingredients that we need. But instability is one of those ingredients. We need moisture, so we think dew point, we think humidity, those types of measurements. Moisture is usually lighter than dry air, so it wants to rise. Again, we're combining this with our instability calculations. Much of our moisture comes up to us from the south, so we get south winds. We typically see a more moist atmosphere coming towards us. You can see this model animation of moisture transporting up into our region from the south. Then we need a source of lift. So something to at least give that air a little bit of a kick upwards, then the instability helps take over from there. Sources of lift might include cold fronts, warm fronts, low pressure systems in general. The way that they're set up is there's inherent lift associated with them. Jet streams also help promote lift even way up in the atmosphere. So these things are all connected at some level. Daytime heating, a hot, humid day, we get enough instability, enough rising air that we can kick off some thunderstorms. Other things that we might see locally would be like a lake breeze boundary. We see those very frequently in the spring and the summer. There's two parts of the thunderstorm that we want to focus on. The first is the updraft. That's how the thunderstorm starts. So we have our unstable air, we have our moist air. It starts to rise. That's called an updraft, the upward rising air. Eventually we get a cloud to develop, and we get maybe our thunderstorm cloud, our cumulonimbus cloud that ultimately develops. And we can identify the rain-free base of the storm, or the area underneath the dark base of the cloud that doesn't have any rain in it. Just a picture in just a second. That's the bottom of the upward motion. Why is it not raining underneath the updraft? Because that air is moving upward, and sometimes very rapidly. If we're going to see something like a wall cloud, which we'll focus on in a few slides too, that's going to be associated with the updraft part of the storm. And then we might notice inflow. So if we're observing a storm, if we're looking into the screen here, we'll show some examples. Air going at our back into the storm that's out in front of us. That's all part of the process. That air is going up into that updraft and helping that storm to basically exist and perhaps strengthen. Here's an example. It's a little dark at the bottom. As we're standing facing the screen here, this kind of dark base, that's our rain-free base. The puffy, billowy clouds, the cumulus towers up above it, all that air is rising up. There's no rain falling in that rising air for the most part, so that's why we're not seeing any rain underneath here. That's going to be our updraft part of the storm. So downdrafts, what goes up must come down, as we say. That's where the air descends out of the storm and then towards the ground. And so this is going to be rain cool. There's going to be precipitation in it. Often has a dark, murky appearance all the way down to ground level. You're not really going to be able to see through it. Might be accompanied by something like a shelf cloud. And in this case, we're likely going to feel outflow as we maybe view that storm, or air descending from the upper parts of the storm, reaching the ground and spreading outward. So we're looking at the downdraft. This is all precipitation falling all the way to the ground. And then we have this shelf cloud out ahead of it. And air is basically rushing probably out somewhere in this general direction. That's the outflow. Who's heard the term wind shear before? Probably everybody if you've been to spotter training, right? That's good. Wind shear, change in wind speed and or direction with height. So as we see our diagrams here, we're kind of at the lower level of the atmosphere. The air is blowing in this direction. This is speed shear. As we go upward, the speed gets faster. That helps create sort of this horizontal flow of motion in the atmosphere. Directional shear, we have winds from maybe out of the southeast at the lowest level, then maybe from the south as we go up from the southwest, further southwest, and so on, up tens of thousands of feet into the atmosphere. Why is wind shear important? Well, it helps to drive storm organization. If we have a little bit of shear, then what tends to happen is the updraft develops, and then the downdraft starts to develop pretty coincidentally or co-located with that, and rain starts to fall through it. So a storm isn't going to last very long if it has rain that starts to fall in the updraft. It's starting to fall apart, basically. If we have shear, we tend to be able to tilt the storm, usually out in the forward direction. Because of the different speeds or the different directions of the wind, it has a tilt. So we can have this upward moving air, this updraft, that can coexist with the downward moving air, which is kind of being pushed downstream or off to the right side of the screen here. And we have more of a balance occurring. So wind shear can help the organization of the storm and can also help determine the longevity of the storm. There's different types of storms too. We classify them into a couple different categories. We have single cells or pulse storms. You can kind of see our generic radar depiction of what these are going to look like. So it might be your pop-up afternoon type thunderstorm, isolated type convection, single updraft, single downdraft. Maybe there's a few others that are spaced out as well. As we get the ingredients to come together a little bit maybe better, let's say, multiple updrafts, multiple downdrafts, multi-cell thunderstorms. So you kind of see the radar depiction. You might see clusters of storms start to develop. I'll show you some radar imagery in just a second. As organization kind of takes another level upward, then we might get a squall line. It's a very concentrated, extended, linear type orientation to thunderstorms. These are dangerous, especially for spotters or folks that are out there, because they're difficult to get away from. You know, they have to probably go over you because you might be driving hundreds of miles to get out of their way in some cases. And then finally, the supercell could be out there on its own. It could be embedded with other storms that are around or co-located with them. Supercells are unique because their updraft does what? Just call it out. Rotates, exactly. So that's part of the reason that we're concerned about wind shear, because wind shear can help aid in the development of rotation. The updraft is actually spinning. That helps the storm to strengthen. The updraft is stronger, and we have potentially more impactful storms as a result. There's also a life cycle to the storm. We kind of sort of touched on this already. Our towering cumulus phase, as we traditionally call it, our updraft starts, the puffy billowy clouds develop, they develop taller and taller. At some point, we get enough of an updraft, we have condensation, we have precipitation falling out, our ingredients start to take over and become more combined, we have shear maybe we have some tilt like we illustrated before, we get a downdraft. So this is the mature stage, we have an updraft and a downdraft occurring simultaneously. At some point, whether it's a matter of minutes or a matter of even hours later, we lose our updraft, no more rising air, no more fuel for the thunderstorm, and the storm starts to dissipate and we're left with a downdraft that'll eventually fade out. All right, so a little bit more about these storm types. So our single cell storms, you're going to see pretty common radar depictions here, I think, in these examples of what we get. We kind of get a variety of types of storms, of course. But daytime heating might drive them. There might be boundaries that drive them. Typically, the atmosphere isn't super favorable for a lot of organization. So we get storms that pop up. They usually last for a short time, then they fall apart. And that's what this radar depiction is showing. We have probably what started as a lake breeze boundary, maybe is enhanced by the outflow coming from these storms that did occur. We have other storms forming further inland, but they're generally out there on their own. They may pulse in intensity, maybe briefly become severe to the point where we get some fairly large hail, maybe some brief damaging straight line type winds or microburst winds. If they're not moving very much, they can produce a pretty high amount of rain in a short amount of time, so we have to worry about flash flooding. Sometimes you might see cold air funnels or land spouts if they're associated with these boundaries as well, but generally a low severe type situation. All these thunderstorms are probably going to have lightning. If they're thunderstorms, they're going to have lightning. All these cells might have lightning, so we always want to be mindful of that. We move up the organization a little bit. The ingredients become a little bit more notable, I guess I could say. We get multi-cells. So another very common radar depiction of our area, clusters of thunderstorms moving across. organization's a little bit better. The likelihood of severe threats might be a little bit higher depending on the conditions, but damaging winds, damaging hail are probably going to be the primary severe threats with this type of multi-cell cluster situation. Flash flooding, again, if they're training one storm after another over the same area, or if they're moving slowly. We do occasionally see tornadoes from these. Typically, they're on the brief and weak side. Squall lines, again, more organization. You can see the real estate that this covers here. This is up near the Wisconsin border. Back here, this is I-74, I believe. That's a lot of distance. So if you're spotting or you're out there, you're going to have to endure whatever these storms are bringing because you probably can't get around them, right? So you're going to have to think about your safety. We're going to go into that next. Highly organized clusters of storms. These can be very severe. We think about derechos and those things, kind of the extreme end of these situations. 80, 90, 100 mile per hour straight line winds, basically situations you don't want to be out in. Destructive winds, tornadoes. There's probably a few in this squall line here. Worst is first. Usually the wind and the heavy rain comes first with the squall line is what we say. But again, they're hard to get around, so they're very dangerous to those that might be out. Here's a top view, a schematic and a schematic. Here's our top view, our heavy rain, the outflow, that outward surging wind, the gusty winds at the leading edge of the storm. The updraft is towards the front, and there's tilt actually back towards the back of the storm, or upwind, and you kind of see this cycle that sort of feeds. More moist air goes up, the downdraft helps push more warm moist air up ahead of it, and this is where we might see our shelf cloud. This sort of outflow and this reflection back up is what helps us get that shelf cloud to develop. Here's a panoramic shot of a shelf cloud. The shelf cloud marks the edge of the cool air, or the cool outflow, or the downdraft from the storm. These can occur with any storm type, but they're common with multi-cell clusters and squall lines. You might have sort of a horizontal rolling motion with these. You know, we're not going to expect vertical rotation with a shelf cloud. Here's a few more examples. One of these is here's our office over here, another panoramic type shot. This one's a little bit more kind of fragmented, the more not as quite well formed. We say the shelf cloud stretches. Usually they're pretty expansive across your view of the sky. Sometimes there's an outward curl near the bottom. All right, supercell thunderstorms. So we talked about why they're supercells. They have rotation. The updraft is rotating like a barber pole, if you've ever seen one of those. Sometimes they're out there by themselves. Sometimes they're mixed in with other storms, so they can be pretty complex, especially in our region. Severe threats, destructive winds, strong tornadoes, or worse, destructive hail, flash flooding. So you get the full range of severe weather and flooding threats with supercell thunderstorms. We can really focus on this idea of a rain-free base underneath our updraft. It's this area here towards, in this case, kind of the back of the storm. Updraft goes up, downdraft towards the front or the leading edge. That's where all the rain and hail falls. Here's a radar depiction. This is from the April 2015 Rochelle-Fairdale tornado. So this supercell thunderstorm they're watching here advancing. So this whole portion of the storm, the updraft, is actually rotating. And so that's one of the reasons we can get this appearance, this hook-like appearance to it, is because what's over here is trying to rotate back around to the other side because it's all spinning, for lack of a better description. So you've heard hook echo if you've been to spotter training before. That's what we're seeing here. That tells us that that thunderstorm is rotating. In this case, we had a strong EF4 times tornado. Here's another supercell. This one is pretty photogenic. In this case, we actually have kind of a smooth, kind of circular appearance to the updraft base. Again, that's an indication that that rotation is occurring. Here's our rain-free base. It's pretty low to the ground in this case, but we can see that, excuse me, that sunset back behind it. No precipitation. We know the air is moving up. That must be our updraft base. Over here, we see all this murkiness, this darkness. That's the air that's descending. That must be the downdraft. This is the area we want to focus on if we come across this type of scene, the updraft. That's where we might see wall clouds. So wall clouds are a lowering of that rain-free cloud base. When we see those develop, the storm is probably organizing or becoming a little bit stronger. And that lowering starts to develop because the air moving into the storm is starting to move in more rapidly, and the upward motion, the updraft, is increasing as well. On a relative sense, they're usually kind of compact. They're nowhere near the expanse of shelf clouds. So that's one delineating factor between the two. Something like fewer than 20% of wall clouds go on to produce tornadoes. We get concerned about wall clouds more so when we see there's rotation in the wall cloud. So remember that thunderstorm updraft of a supercell is rotating. And if that rotation manages to manifest itself in the wall cloud, then we may be on the way to having a tornado. So again, a lot of wall clouds, fewer number of tornadoes, so it's not a guarantee. But we want to know if that rotation is rapid in the wall cloud, if you see a lot of rapid rising motion in the scud clouds around it. As this occurs, if we're standing at any of these vantage points looking at these storms from where we're sitting, that inflow wind might increase at our back, and it'd be accelerating into that storm. So if you're not seeing a wall cloud and that inflow increases as you notice it, you might start to see a wall cloud. Or maybe you're seeing one, maybe it starts to rotate, maybe that rotation stops, maybe that inflow wind is sort of coincidentally decreasing as well. So there's some clues you can look for to kind of identify what's happening. From a reporting standpoint, we want to know about a rotating wall cloud. We'll go into more reports in just a little bit. Here are some examples. Pretty typical example, at least for around here, pretty ragged, but you can see here's kind of the original cloud base. There's no precipitation falling over here. You could watch, if you're patient as a spotter, watch the towers probably build upward. Downdraft is over here. This lowering is kind of what we're looking at. There's another fairly photogenic one too. A little bit broader, kind of this whole base is sort of interesting to look at. But again, are we seeing rotation? Are we seeing anything of interest in that regard? Some more examples. This wall cloud down here. Rain-free base. So regardless if you're not exactly sure what you're seeing, because some of these are not clear-cut examples, think about those fundamentals. Are you looking at a rain-free base? Are you seeing a lowering develop? Do you see rotation there or not? This one's not great contrast because the rain is back behind it, but you can see this wall cloud here. Here we have a shelf cloud coming in over the city. Not the best, excuse me, not the best organized one, but you can see that expansiveness. If we were sitting here watching this, it would be moving off towards our left, and we'd be able to see this precipitation advancing towards the left with it. All right, so complicating things. Gustnadoes, land spouts, cold air funnels, water spouts. These all develop when we have non-rotating updrafts that stretch, and then we get this spinning that occurs usually closer to the ground level. We won't go into a lot of detail on this. Gustnadoes, we get a lot of reports of what is ultimately blowing dust at the leading edge of the outflow of thunderstorms. So there might be a shelf cloud overhead, there might not be. That air is accelerating out of the storm, friction and other things, it kicks up dust, it might start to whirl. Sort of the bottom line with anything that is maybe confusing, not clear-cut, is to think about what part of the storm we're looking at first of all. Do you notice the rain-free base or not? And probably more importantly is, do you see rotation both at the ground level and at the cloud base? So if you're seeing something spinning, it's connected to the ground, do you have rotation up the cloud base that you can connect that to? If so, then we certainly want to know about that because it's probably a tornado. If you don't see that connection at the cloud base, then it's probably blowing dust. Doesn't mean we don't want to know about it, but in terms of what you're going to report, that might give us a better description of what's happening. And that's usually the best course of action. If you're not sure of what you're seeing, describe to us, if you're going to contact us, what you're seeing, and we can put it together with other pieces of information to figure it out or help figure it out. The key is to look up, do you see a rotating wall cloud or rotation in the cloud base? If not, it's probably not a tornado. In our full spotter training, just a quick plug, we're going to do some virtual sessions coming up in April. We'll show some videos that kind of outline this more specifically. There we go. Other scary looking clouds are scud clouds, stratocumulus under deck. Look for visual clues before reporting a funnel cloud. This looks pretty strange here. Well, what else is going on? And again, it's really about looking at the cloud base. Do you have rotation in the cloud base or not? SCUD is good. It helps you see that vertical motion. It might help you see the rotation as well. But you have to think, take a minute, assess the situation, and ultimately decide, do you see rotation of the cloud base or not? All right, so planning, preparing, and safety. So I'm guessing this crowd probably checks the weather on a regular basis, right? Okay, so just so you have some specifics and some reminders, daily weather assessment. So you're all probably doing this. Get your friends, family, coworkers, and other folks in your life to do it too. That's the idea, especially when you know there's a thunderstorm potential. If they can't do it every day, at least get them to focus on days when there's a thunderstorm chance. Ultimately, there's two steps. Your weather assessment that's basically going to ask, what's the weather going to do? Do I need to be concerned? So am I going to go out spotting? Do I have an event after work? Kids have a babysitter this afternoon. Do I need to make sure they're ready in case there's warnings, that they know what to do? All these types of things. Put yourself in the situation that is possible later in the day and think about what you're going to have to do to be ready for it. Step two is, once you've made that assessment, pay attention to the weather and be ready to take action if you have to. All right, so I'm sure everyone is familiar with Storm Prediction Center outlooks. A 5-category scale. The teaser here is most of our severe weather happens right in the middle of the scale. And even some of the more notable events we've had have fallen somewhere in this middle part of the scale. So Rochelle-Fairdale was in the level 3 or enhanced part of the scale. Naperville-Woodridge as well. I think, let's see what other ones. There's a few other ones too. There's a couple February events, believe it or not, that also fell into that range. So don't discount what the scale is saying or where it falls. The high end are much less frequent for us, fortunately. But just things to keep in mind. And these outlooks go out to 7 days. So for situational awareness, those signals are often pretty good that far out. So you can keep an eye on these things and help determine your confidence in the situation. We put a lot of graphics out nowadays. We call them weather story graphics. They're going to go to our social media feeds. They're going to be on our website. And we focus very specifically on what, when, and where, and try to boil down a lot of complex stuff, a lot of potential, a lot of uncertainty sometimes, into information that you can use. So you're going to find those on our website. And there may be several graphics for any given situation. If we maybe have to focus on timing, then maybe the magnitude, or maybe there's also flooding beyond just the severe threat. So we may have several graphics, and they're going to rotate through on the website. Website, of course, is weather.gov or weather.gov/Chicago. Hazardous Weather Outlook is a text version of the what, when, and where. Looks out the next 7 days. When do we expect weather hazards, whether it's severe thunderstorms or winter storms? We do it all year round. There's graphical versions of that you can also find in our current hazards menu on the website. It's a good quick look. It also plays on the weather radio. We put information about storm motion in here. That's certainly very important from a safety standpoint. In this case, storms are moving at 65 miles per hour, expected to. So again, that can be very dangerous. We'll go into that in just a minute. Forecast discussion. Paul referenced these already, kind of the why of what we're thinking. Maybe talk about our confidence level or alternate scenarios, things we're going to have to keep an eye on that are not quite clear yet. Ask yourself, so we've done kind of our assessment. We know there's a risk. How are we going to pay attention to that risk as it evolves throughout our day? Well, watches might be issued. Not every severe event has a watch because it may not be warranted based on thresholds and that type of thing, but there might be a watch. That's your heads up. Things might start to happen. If you haven't been paying attention, now is the time to start paying attention. Graphical updates. We try to fit what we call the watch to warning gap with information. Sometimes storms take a few hours to arrive or to develop after a watch is issued. We want to keep people apprised of the situation. How is it evolving? Are they starting to develop? Has the timing changed? What are we watching? And keep a flow of information going. And then finally, warnings. Warnings mean take action, right? So hopefully you've been paying attention prior to that time. Just to be clear, because there's always questions about a watch versus a warning, watch means pay attention. Be alert. Things are becoming favorable. They might start to happen in the next few hours. Warning means take action. Put that plan that you hopefully have in place, actually activate it. Go to your safe spot, do what you need to do. All right, so safety. Safety is paramount for everybody in the room, spotter or not, of course. That's our main goal, is provide information to help keep people safe. If you're out spotting, only spot where you have a good view. Certainly that can be challenging in a metro area. Night spotting is difficult to impossible, and we say don't do it, honestly. Always be aware of your surroundings. Are there other storms developing nearby? Maybe they're developing over your head, so have your head on a swivel, 360 degrees, but also up above you. How are you going to get away from that storm? We talk about those squall lines, right? There's no way to get away from them in a lot of cases. So you have to keep driving to St. Louis, and you're probably not going to outrun that storm. If you are seeing something like a supercell or a tornado forms, are you in a good place to get distance between you and it? Spot with a partner if you can. We're in a day and age of photos and video and access to data on the internet and our phones and everything else. If you're going to be out there, especially mobile, have someone to drive and someone to do everything else. Again, not just storm safety, but safety in your vehicle and otherwise. Of course, we don't encourage storm chasing, and we're never going to ask a spotter to get closer to a storm or anything like that. Safety is number one. We have other tools, we have other reports likely that people can make that we can use. It's not worth risking safety just to make a report. Otherwise, it's best to stay indoors when severe weather threatens, right? If outdoors, some general rules: find a sturdy structure. The real goal here is to be planned well enough ahead of time, have good enough awareness that you don't get into situations that are like these, where you don't have a good safety option, or you're, getting out of your car into a ditch when you could have been in a safe place, had you paid attention more to the weather and found an alternate route or something like that. But if you find yourself in these situations, in a vehicle, last resort, lie flat in a ditch or low spot. Don't go under overpasses. We've been trying to break that myth for a long time now, literally decades. Don't try to run a tornado, especially around here. We know about traffic, right? Tornadoes can move 60 miles an hour or more. The general rule is move indoors to a sturdy building, go to the lowest floor, put as many walls between you and the outside and as few windows. And it's about finding the best situation or the best option that you can. There may not be a 100% safe option, but you want to work yourself up that scale to doing the best you can. Remain indoors until the warning expires for your area. Then you can assess, take a look out the window for damage or whatever else you might have to do. And that report, again, can wait. Your safety is paramount. Lightning. Every thunderstorm has lightning. You need lightning to get thunder. When thunder roars, go indoors, right? So this is a rule we probably all know, but maybe not all of us follow all the time. Most people that are hit by lightning, they either waited too long to go to a safe spot, or they left their safe spot too soon. They get struck when there's no rain falling in a lot of cases. So again, it's about preparation, avoiding the situation in the first place, but if you're out there, your hair starts to stand on end or something like that, you basically run for it. Run for the safest spot you can find. Hardtop vehicles are generally safe. There's a whole long list on our website that we can point you to for a lot of the details, but you don't want to be outside when there's lightning. So reporting. We want to know about tornadoes, right? We cover this in spotter training. We'll have a download at those virtual sessions in April. Again, tornado rotation at the cloud base, rotation at the ground. You may not see the connection in between, at least right away. Funnel clouds, again, is there that rotation at the cloud base. Wall clouds, generally, you can report wall clouds if you want to, but really report the ones that might be rotating, especially if they're rapidly rotating or kind of low hanging to the ground and rotating. Tell us where you are, and then approximately how far and in what direction the feature you're looking at is. It's going to be an estimate, we know that. We can use other tools to put the pieces together, but we need to know where you are and what you're looking at. Hail, if you have the ability to safely measure it, that's great. Otherwise, kind of estimate it based on the size of like coins or game balls. Please don't ever report marble-sized hail. Those are all marbles over on the right side of the screen. They're all different size hail. Tell us about damage. Tell us what the wind did. Unless you have a way to measure the wind, just tell us what it did, because we have a really good tendency to overestimate wind speed. My trash cans are blown around. I have a 3-inch diameter branch down. My 12-inch diameter such and such tree was snapped at the bottom. There's shingles missing from my roof. This kind of gives you an idea of the scale of the wind speed we might be looking at to cause those things, but I can't tell you how many reports of like 80-mile-per-hour winds we receive, and we start to follow up. Well, did you have any damage? No. Your trash cans move? No. Do you have a trampoline? Yes. Is it still there? Yes. Probably not 80-mile-per-hour winds. So tell us what the wind did. Flash flooding, of course, never drive through a flooded roadway or anywhere else. Don't go into the water. Flash flooding that water rises, that happens very quickly. A lot of urban flooding that we get, there might be a low viaduct that you cross. Maybe if you're out in a rural area, there's kind of a low crossing that tends to fill up with water at night. If you get a lot of heavy rain, think about those things as you go through your day. Did you get heavy rain? Do you need to alter your route? Most flash flooding fatalities occur at vehicles and at night. Tell us about how much rain you have. Tell us if you see observed flooding such as these in the photos. The bottom line is tell us who you are. I'm a trained spotter. What you're reporting, when it occurred, and where it occurred at. So maybe you come home from work or something and you've got a big tree down in your yard. You don't know when it happened, but tell us it happened. We can take that information, we can figure it out. Who, what, when, where. Be specific with your location if you can. Crossroads, address, those are all helpful information. Tell us what county you're in. A lot of towns even have the same street names as other towns. So be as specific as you can. And don't be overconfident. Don't be shy about reporting either. Just tell us what you're seeing. We can ask you some questions that help follow up. We can put your information with other reports and other tools to figure out what we think is going on. So don't be shy about reporting to us. How do you report? We have an 800 number. Feel free to put that in your phone or take a picture of it. Urgent situations, I see a tornado on the ground, that type of thing. Best to call us. Otherwise, you can find us on social media. Sometimes it's easier just to send a picture or video, right? Picture is worth 1,000 words. We have our office email address. We may ask you to provide pictures there if you call us with something. Amateur radio, our amateur radio information is at that website. We have a reporting website. Yeah, take a picture of that link. It's nice and long. It's on our homepage as well. You can submit a report online. It alerts at our workstations. Spotter Network is another organization that reports information directly to us as well. Again, if you have urgent information, it's best to call us or voice it to us in some way so we get it as quick as we can, because we turn that information around to help people downstream that haven't been affected have a good understanding of what's actually happening. All right. That's all I have. Thank you.